In this next segment, we're going to look at a linked list, and this is our first example of what we're going to learn is a recursive data structure. So it is a data structure where one object of this list can refer to other objects of the same type. Right? And that gets into the weeds of where what we'll see is the implementation of a linked list later. For now, let's think about what is a linked list and try and identify some of its properties. So a list might be empty. The empty list is just null. And we'll see that in our programming language, we'll use the keyword null to represent this. And in diagrams, we might use the circle with a slash through it to indicate there's nothing here. This is an empty list, it's null. A list is a sequence of one or more values of the same type. So Michael followed by Kevin followed by Pam, these are all strings. And each of these string values is followed by some other string value or the empty list, which designates the end of our list. 101 followed by 110, we've got a sequence of values that are numbers. Each item in our list is called a node, right? So this is a separate piece of terminology from, say, arrays, where each item in an array we call it an element. In a list, each item is called a node, and they're individual from one another. Whereas with arrays, they are all part of the same sequence of memory. With our lists, we're going to see these are individual objects that one node is followed by some other object also of type node, and that will be some other place in the heap until ultimately we get to the null or empty list, which is the end of our list, and we designate that as a special value, saying this is where our list ends. This is where we know that we've reached the end of our list once we've reached the null value or the empty list. So these are what we would define a linked list in terms of. So let's actually think about what are the operations we can carry out on a list. And the good news is there's only 3 things that we need to be able to do with a list in order to start to build more advanced algorithms on top of it. And to add additional capabilities or additional operations can be expressed in terms of these 3 simple things we can do with a list. So the first thing we can do is we can construct a list. And the way that we construct a list is we put a new node at the front of some other pre-existing list. So there's going to be a function named cons built in our library that's short for construct, and we're going to construct a node at the front of some other list. Okay, we'll explore these in detail in just a moment. The other thing that we can do with another thing we can do with a list is we can ask it for its first value. So we can say, hey, list, give me your first value. And the last thing we can do with a list is we can ask the list for the sublist of everything except for the first value. So what comes after the first value with the rest function. And that's it. These are the only 3 functions we need in order to start writing programs that operate in terms of lists and to start building more advanced capabilities, as we'll do in the next problem set and in practice problems later in this lesson. Right? So these 3 simple operations are going to be our building blocks for building more advanced functionality. So let's talk about how do we construct a list, and we do this value by value, right? So each time we cons a list or we construct a list, we're going to give the cons function 2 parameters, the value that we're adding on to the front of the list, and then the list that we're adding that value onto. What cons will return is a brand new list with the value that we just added onto the front of it as the first node in that list. So for example, if we wanted to make a list of string values with the first value of that list being Kevin, we can write a function call that will look like this, right? Cons the string Kevin onto the empty list, or cons the string Kevin onto null, right? And this will result in a list with one node in it, and that node will be followed by null or the empty list. We can construct a list with 2 values in it by nesting that function call, right? So if this inner function call resulted in a list with 1 element in it, followed by null, then what we're saying is cons Roy, or construct a list where Roy is the first value, followed by the list where Kevin is the first value, followed by null. Additionally, if we had a pre-existing variable who was set up to be the list Roy followed by Kevin, we can also use variables here, right? So if the list names referred to, or if the variable names referred to the list where Roy is followed by Kevin is followed by null, then this last line of code would cons or construct a list where Ramses is the first element in it, followed by Roy, followed by Kevin, followed by null. So let's actually try playing with this in our example. And the example code we're going to use in today's lecture is actually the O2 Lists app. Right? And so when we run this, we see that the first time we print the list and we print this list value concatenated here, we get a string representation that's built into our library. So notice we're importing the functions cons, first, and rest from the intro CS list library. And then node is the name of a class that is type node string here. And we'll explain this syntax here in just a moment. We're saying that list is going to be made up of a node of type string. And each node then will have to be a string value. And here we're consing C onto the empty list. And that's what results in a list where C is followed by null. Right? So we could also cons, say, N onto this list that we had set up before. And notice, just like in the slide that we saw previously, if we construct a list where N is added to the front of the list where C is added to the front of the list that is empty, we get N followed by C followed by null, or N is a list that is followed by a C node that is followed by a null node, or nothing, I should say. Null is not technically a node. Okay. Additionally, as we saw in the example, we can add another example here. We can cons U onto the list itself, right? And so what we're saying here is take the current list. We're going to construct a new list where U is at the front of it, followed by the list value that we gave coming in, so NC, and reassign the resulting brand new list back to list, right? And so the first time around when we printed list value was N followed by C followed by null, but then we consed U onto that list, and so it became the list of U followed by N followed by C. The next function in this trio of functions is first, and the first function allows you to ask a list for its first value. It's as self-explanatory as hopefully it sounds, right? So when you ask a list that is non-empty for its first value, it gives you back whatever is at the front of the list. However, if you ask an empty list for its first value, you will get an error because you can't ask an empty list for its first value. There is no first value for you to read from an empty list. Right? So the first function is always going to require one parameter, and that's going to be a non-empty list. Here in this example where we have a series of cons 10 onto cons 20 onto cons 30 onto null, or 10 followed by 20 followed by 30 followed by null. If we ask this series for its first value, we would get 10 back out of it, right? Because that will be the first value of this sequence or this list, right? So once again, if we have a list where Ramses is followed by Roy is followed by Kevin, followed by the empty list, we ask that list for its first value, and it would be the string Ramses. We ask the empty list for its first value, and we will get an error. All right. So let's try actually using this function really quickly. If we go back to today's code, we can try, say, printing first of list is going to be concatenated with the result of calling first on that list value, right? And so sure enough, this call to first of list, once you add it and you print it out, we can see that that first value that is printed after we added on U to it would be the letter or the string U, right? Just to prove that if we accidentally were to call first of null, which is our empty list, what we'll see is an error message that says, hey, you can't call first on null or the empty list. That's an invalid function call because we need a list with at least one item or node in it in order for the first value to have meaning. All right. So the last of these three functions is the rest function. And what this will do is it will return a sublist, or the list that follows the first node. Right? So rest will return a list with every value except for the first node of the list that you gave it. Right? So if we once again use the series of 10, 20, 30, and we said rest of series, what we would get back is 20 followed by 30 followed by null. So for example, if we have rest of Ramses, Roy, Kevin, we're going to get back the list of Roy and followed by Kevin followed by null. If we ask the list of Kevin followed by null for its rest, we would just go back to the empty list. And if we asked, just like with first, for the rest of the empty list, we will see that there's an error. Right? So the next thing I'd like to try doing is looking at how do we access particular values in our list. Right? So how do we access the n or the c? Right? So maybe what we'll try doing is adding some print statements such as second value. And I'm going to leave that empty for now. We're going to come back to it in third value. Right? So I'm adding two print statements here. And what I would like to do is print out second value followed by whatever that value is concatenate onto that string. So I'm going to add a concatenation operation. And if we ask the first of this list for the value, we would see that sure enough, we get u, just like we did before. So what do we want to do here? Well, what we want is the rest of the list. So the rest of the list that we're seeing here, the first value of the rest of the list, right? So the first value of the rest of the list. Right? And so sure enough, that gives us n. And the same concept we can imagine being applied to the first value of the rest of the list. All right. And that gives us the C. All right. So I'm going to slow down here for a moment and give you a chance to try catching up to the code that I've got. And while you're doing so, I can try and explain a few things here. So one of the common questions that comes up in lecture at about this point is, wow, Chris, this really feels like we're having to go through a lot of extra effort to access the items of a list than we did with an array. So why are we going to all of this effort? Well, what we're seeing here for the first time is, as I mentioned before, a recursive data structure, right? So the node u is going to refer to another node of type n, and that we'll keep having objects which recur to other objects of the exact same type until finally we reach what will effectively be the base case of a recursive data type where there is no next object and we've reached the end of some recursive data structure. And the reason why we're starting with a list while we're trying to introduce the concept of recursion is that we've found that these two ideas, when you learn them together, they pair very nicely. Right? So you're not really ever going to write code that looks like this, where this would be really painful if you wanted the 50th element of a list. To write it out yourself like this would be extremely excruciating, right? And so what we're going to see is you're not going to write code that looks like that. But this idea that we might be calling rest followed by rest, there's a pattern here of how we access subsequent values in some list. We're going to see that pattern really pairs nicely with the idea of a recursive function that processes a list. And that's what we're going to look at in the next video. But to just give a quick hint of this, if we wanted to go through and visit recursively each element or each node in this list, what we would have to do is say, okay, I'm going to write a recursive function. You give it a list. And if that list is non-empty, you're going to print out the first value and then move to the next the rest of the list with a recursive call. And so each recursive call will be passing in the rest of the list and moving our way node by node through a given list. Right? And so we're going to go on a little bit of trust here that this is actually going to make learning recursion feel a little bit more tangible than it would if we took a mathematical approach where we focused on Fibonacci sequences or factorials and concepts that you've seen in math, but are very dry and very boring. What we've found is that learning recursion and how to write recursive functions and think recursively, it's much easier to do when we do that in terms of a list. And this has been true for quite some time in computer science.